Hello and welcome to the Roundtable Podcast. My name is Shogun. Tonight we will be discussing quantum physics, a very interesting subject I know very little about. I'm eager to learn with my good friend Technoshaman. But before we get started, please make sure you follow and subscribe to the podcast on YouTube and BitChute, where you can find over 200 awesome episodes. Most of all, please make sure you join us on the Roundtable Discord server, where we record this podcast every day at 8 p.m. Central. That being said, welcome, my friend Technoshaman. How are you, sir?
Doing quite well. How about yourself?
I am very well, thank you. Had a good day. Looking forward to learning about quantum physics. I apologize, my cat is being particularly vocal today. But so long story short, I think a lot of people are interested in quantum physics. I don't know. Most may know something about it, but I know very little. So can you just give us an introduction to it, why it interests you, or what you know about it, just as an introductory statement about it?
I'll start off with an overview of the scientific method. It's the most powerful tool for understanding the cosmos that we have at our disposal. And the power of it comes from the fact that it tries to falsify itself. So it's continually honing towards the truth with greater and greater approximations. And quantum physics is one of the most powerful approximations we have to billions to many decimal places. I can't remember the exact number, but it's a huge amount of accuracy, and it's fascinating how we've been able to hone our knowledge over the past 500 years more than the rest of human history because of these set of techniques, and it's valuable, as a tool for understanding, and because so much of our society runs on technology. I mean, we're communicating right now utilizing quantum physics. We're all sorts of protocol mechanisms and whatnot are utilized to allow us to communicate across the globe, and being informed about it is super helpful.
So I understand what you're saying, and I agree. Scientific method and science is super important. So that's the general picture, but more specifically, can you give us a 101 on quantum physics? So what is quantum physics?
So the quantum part of it stands for it being quantized, which means it jumps occur in small, discrete steps, the smallest discrete steps possible. So instead of a continuous orbit, such as would occur for celestial bodies, an electron only has specific configurations it can adhere to around the atom, and this was discovered in part due to the ultraviolet crisis, and that was because classical models, when describing the light in a black body radiation system, which is basically a box with a hole in it, and you measure the light from the box that's emitted based on heat, it goes off into exponential growth in the ultraviolet range, which makes no sense from what is measured. It actually tapers down, and when quantization is applied, the right result occurs.
That's fascinating. So the only thing I really do know about quantum physics is like thought experiments, like Schrodinger's cat, I think, has to do with quantum physics. And if I'm not mistaken, this is the wave and the particle thing, how a particle is somehow both a wave and a particle until it's observed. And that's why the cat is simultaneously dead or alive until something is observing it, because that would trigger the collapse of a particle that would trigger the gas that would kill the cat or something like that. Is any of that true or familiar to you?
Yes, that it, yeah, the wave particle duality. That everything is both a particle and wave at the same time. Um, and instead of interestingly, it's probabilities that are transmitted. So it occurs in the form of a probability wave. Um, that um, it transmits the probability of it being in a specific position, and if the accuracy of the position goes up, then the accuracy of its momentum goes down, because there's a fundamental limit, called Heisenberg's uncertainty principle. It says there's a fundamental limit to how accurate we can know about things in this cosmos. You can think of it as an example of a tennis ball. You throw a light paper ball at it, then you would know its position pretty well. But if you threw something heavier at it, it would move it. So you would get its position, but you wouldn't. It would change its momentum. So any measurement you make actually changes the system. So that's the whole idea, that the observer changes the properties of the observed. And there's been clever experiments that move the observer a couple steps back, but there's still an observer involved at some point.
Can you do me a favor and just sum that up real quick in like a 30-second?
Sure.
Thank you.
So position and momentum are tied to each other, and the greater the accuracy of the one, the less of the accuracy of the other.
All right, so there's a few more things I want to talk about for sure, and then we'll open it up for audience participation. But just a quick one or two more questions. So can you speak about, or are you aware of something called like spooky action at a distance, which is what Einstein called it? I believe it's a quantum phenomenon, and I think it has to do with like one particle being vibrated or influenced in some way, and then another particle that's paired reacting instantaneously in a way that is faster than the speed of light, essentially. Can you tell us anything about that?
Yes. It was initially thought to violate this fundamental speed limit of the universe, the speed of light. But it turns out that it has to do with entanglement, where the properties of, say you have a spin up or a spin up electron, and you tie it to another electron such that that if you flip it to spin down, then the other electron has to be one way or the other, and you can measure the other electron. So they're entangled. And as a result of that, if you move the other electron further away from it, then you flip the spin, you know the other electrons spin instantly, but you still had to move the electron slower than the speed of light. So it doesn't violate the speed limit of the universe, but it does seem like it does.
Thank you. So another thing that I know you have a lot of interest in is the idea of quantum immortality and how that pertains to another thing called quantum suicide. And I think this is very interesting. So can you tell us about this a little bit?
Certainly. It's an extension of the Schrodinger's cat experiment. So there's a couple different interpretations in quantum physics. The two main ones are the Copenhagen interpretation and the many worlds hypothesis. And the Copenhagen interpretation is basically just do the math and the result comes out. But the many worlds hypothesis states that each time a measurement is made in the universe, the universe splits, and both possibilities exist, but you end up in the one where the measurement is made in whatever direction the measurement turns out. And in the case of Schrodinger's cat, it's tied to its consciousness. So the consciousness will continue in one of the universes and die in the other. So from the cat's perspective, if it dies, then it's not existing anymore, but its consciousness continues on because there's always one universe that it splits off in, that where it survives. And it from the cat's perspective, it's immortal, and it just hears a clicking sound where the thing that the radiation that's supposed to set off the poison just doesn't go off, and it continually does that. And if I remember correctly, it has to be get down to a binary decision at the end. So I guess dead and alive would be about as binary as a living system can get.
So I think you had like a sense that you had a personal experience with quantum immortality and quantum suicide. Are you able to talk about that a little bit?
Actually, a couple of times. Yeah, I made the decision in around 2014 to test the many worlds hypothesis. I figured I didn't know how I was going to do it, but I decided to, and I've been faced with situations in my life that should have killed me, and I've managed to survive. It won't go into too many details, but one of them it involved situation where I was found and I shouldn't have been, and I managed to survive that situation. There's in the next podcast I'll go into a situation that is even more freaky and but I guess another time I was walking down a road and felt like I was nearly injured, and it should have been by all intents and purposes, but I ran to the side and made it home. And at night I heard I can't discount the other possibilities going on, but it just seems very strange that I keep on having these near-death experiences that I managed to survive. Since
Absolutely.
making that decision.
Thank you. So I have plenty more questions I'd be happy to ask, but I think we should open it up for audience participation as well. So if anybody has questions or comments for Techno, go ahead now, and otherwise I'll just continue the interview.
I got a question.
Go ahead.
So you said that you tested out this hypothesis on what was it called again?
It's the immortal cat, or quantum suicide and immortality.
So what led you and what persuaded you to test it out?
I wanted to see what type of universe we lived in. I figured I learned about the experiment. I figured it would be interesting to step into that role and become a Schrodinger's human. And worst case scenario is the other state I end up in. But yeah.
One last question. What you found out, did it change the way you see Earth? Did it change your perception on the Earth?
Yeah, it helps me to see that we're in a much faster universe than we could otherwise imagine. It's these potential parallel worlds, and you can hop between them. And
Well, also, when you imagine the Schrodinger's cat experiment from perspective of anyone but the cat, there's going to be a world where the scientists find the cat alive and a world where the scientists find the cat dead. So, like, if you keep performing this experiment, in the eyes of other conscious observers, there will be worlds in which you didn't make it.
oh, yeah, I guess that gets to the problem of whether the universe is discrete or infinite, which is, well, now, I mean, there's a cosmic horizon, but we don't know whether the universe is finite or infinite. And yeah, I should be careful.
I have a question. Do you feel that in any way simulation theory plays into quantum mechanics? And how so?
Absolutely. It could be such that the the quantum mechanics it acts where each atom is its own computer of sorts, and the physics are set up such that it does these calculations automatically. And there's if you get into theories relating to black holes and the holographic hypothesis, it the the it's starting to find that information may be even more fundamental than energy and matter to the cosmos, where they're finding stuff like Claude Shannon's law of information entropy showing up in the physics they're digging into when it comes to the holographic hypothesis for black holes.
Okay.
Oh yeah, I got one last question. Sorry, for Technoshaman. Do you believe in the black hole to white hole theory?
I'm not too familiar with that. That my working hypothesis is a type of a cyclical universe where it starts with a quantum fluctuation, and you get somewhere in the middle where we're at. Then you're left with the black holes after entropy moves after entropy does its thing. The black holes dissipate through Hawking radiation, and then you reach a state of special nothingness again. And that special nothingness will eventually have another quantum fluctuation, and then a new configuration arises with different parameters. That's one working hypothesis. And then there's the multiverse idea, where we're existing in bubbles in a multiverse of interconnected universes that are in a megaverse. And that what hints at that is the way things have scaled, where at first we thought there was only one planet, and then we discover we're in a galaxy, and then we discover there's multiple galaxies, billions upon billions of galaxies, and so on. and then you extend that, you extrapolate that upwards.
Have you ever heard by any chance of the concept of quantum tubules, quantum nanotubules in the brain? It might be kind of obscure, but
Um,
not really.
I,
I mean,
I the they I know that nanotubes are great conductors of electricity and can have a lot of funky properties that could be taken advantage of with enough technological sophistication.
yeah, I know very little about this, but my understanding is there's structures in the human brain called nanotubules, which somehow have some quantum properties, and some scientists have suggested that this could be a mechanism for the persistence of life after death. I'll have to post the sources about this, or somehow some of these psychic phenomenon and spiritual things might be a quantum effect produced in the brain or something, but I can't say anything more about that, and I don't know if it's valid or not. I'm just fishing through my mind for the different things I've heard about quantum physics.
I'll take a different approach to this. With 3.5 billion years of life, it would be strange for life not to take advantage of quantum effects, and it shows up in so many different phenomena, such as how chlorophyll is able to utilize light to move electrons around and create sugars, and how the mitochondria are able to utilize oxygen to create a large amount of adenosine triphosphate. So quantum effects are harnessed, and I wouldn't be surprised. And I would almost expect with this much time going on that life has taken advantage of quantum effects to the point where I've heard studies where they tested showing images of of just average objects and porn, and there's a response that was detected before the porn was shown, and this hints that quantum effects could lead to people finding mates in life and so on. But that's more speculative. But it it's intriguing that, and to think that we could be taking advantage of nonlinear temporal effects in quantum physics to directly affect the course of our lives.
Mr. Technoshaman, if I may, how do you think this affects the way we measure probability? Because I take it that asking now what is the probability of some event happening is incoherent, since the event will both happen and not happen on the multiple world hypothesis. Do you have some way of dealing with that problem, or maybe do you not see it as a problem at all?
Well, yeah, there's the possibility that the general wave function never collapses. That I've encountered before, and then that hints at ideas that we're I'm getting at the edge of my knowledge now, but yeah.
That's fair. That's a bit of an unfair question. I also wanted to ask the eye. There's the eye, and then there's Jigmo. I take it Jigmo applies to a lot of different entities across many worlds. Does the eye also apply to all those entities, or does it only apply to the being in this world? If that makes any sense.
Oh well, I see the sense of self as a sort of a VR system where that the sense of I is it's just a construct used to help survival, and that there is really no eye to any of us, that we're all composite phenomenon are impermanent, and there's no real sense of self except for artificial designations. And for example, like when is the dead skin on your body, it's no longer part of your body, or no longer part of yourself. It's an almost continuous function. I guess it gets down to the atomic level at a certain point, but yeah, I don't see a strict separation of selfness. It's more an interacting field of consciousness with peaks and valleys that line up to a self, but which spread out beyond the self.
If I may, very last question, because I want to kind of press that. There's this case of the quantum Russian roulette game. So if I offered you a Russian roulette game where you play Russian roulette, and every time you win, you make money, and you can do this for as long as possible. On your interpretation of reality, would you play this game infinitely until you become very, very, very rich without any fear?
I don't know whether the universe seems to be both finite and infinite at the same time in a strange way, because we're going to step outside of quantum physics for a little bit, because of relativity acts in a continuous fashion. Now it may be quantized, but we don't know. But even then, we don't know the extent of the universe beyond the cosmic horizon, and there are many older thought experiments which lead us to infinities. But in physics, though, when an infinity shows up, that tends to indicate that the mathematics of what's going on hasn't been discovered fully. And so when physicists are talking about singularities, they don't think it's an infinite singularity. They just don't know the math of and anatomy of what's going on when it gets down to those levels.
Right.
So I probably would be sorry. I didn't. I probably wouldn't play the Russian roulette game, even though I infinitely.
Would you play it? So to rephrase the question, if I gave you the opportunity to play it 600 times over, finite amount of times in a finite space time or time, would you take that opportunity if you made a lot of money off of it? And if not, why not? And if yes, why yes?
Well, if you change the money to alleviating suffering, I would do it infinitely. Even with the risk of it being a finite universe. But yeah, the 600 would be a small enough number compared to how often universe is splitting, which would be some around Planck time, which is a very small number.
I have a question. Why is it that we think that consciousness can't really like die, in the sense that, according to quantum mechanics and Schrodinger's cat, they state how since consciousness, the belief of consciousness not being able to die is why it will be carried on somewhere, that's what it goes into. Why is it that they believe it? I'm sorry. Why is it that they believe consciousness can't die? Like, how come maybe it just does die and it's hard for us to comprehend since we can't comprehend non-existence?
It's quite possible. I've reduced it to the point of the debate of whether we live in a finite or an infinite universe, which I don't know which one we live in. If it's finite, it's almost certain we're in a type of simulation just because of the way discrete systems work. If it's infinite, it's something hard to put into words, if not able to be put into words. Just hard to be able to describe it all.
I have another question. Entertaining the idea of simulation theory, right? What world do you think is the world that we would, quote unquote, actually be in? And I mean that in the terms of the world right before us, considering if simulation theory is accurate, we would probably be in an infinite number of simulations at this point, supposing that the simulation could create a simulation in that simulation. But that's regardless. What type of world do you think we came in before this, if simulation theory is accurate?
It's hard to speculate on a world that we potentially wiped our memories of for some reason. Could be either a really boring world or one that we had pressing problems to learn from and needed to enter into a world like this with all its intense ups and downs to learn and grow from.
This one's more comical. But how would you feel about if you were to, suddenly, let's say you were like doing something and you fell off a ladder and you were to pass away, right? You died. And all of a sudden you get sucked back and you're like holding a pipe with a bunch of people around you saying, dude, how did it feel? I know it's kind of silly, but how would you feel if we're in some other type of world, but in this world it has a type of quote unquote psychedelic that would create an entire new kind of life and reality for the person for a time being?
That'd be fascinating. That harkens to the episode of Rick and Morty where they're playing Roy, where they
Yeah.
life good lived, life well lived. Yeah. But yeah, it would be fascinating. I would do my best to apply the lessons I'll learn.
So, are there any other aspects of quantum physics or quantum phenomenon you wanted to make sure you talk about in this episode, Technoshaman? Any other angle on it or comments about it you wanted to make?
Not that I can think of at the moment. We covered a lot of area.
I agree. That was excellent. Thank you. We'll ask the audience as well. Did anyone have another question or comment for Technoshaman?
Can I ask my final question? Very final one. Just to understand how this works, because I'm not very familiar with the many worlds hypothesis. Say I am choosing numbers for a lottery ticket. Before I choose the numbers, I assume that there's a splitting, and I could technically choose any given set of numbers. Would it be fair to say, if I'm understanding you correctly, that there's some Jigmo at the point of time of buying the lottery ticket that has the right numbers that win him the millions of dollars? Is that not how splitting works?
Yeah, that's exactly how it works. There's a probability, quite low when it comes to the lottery, but there's a probability, and that portion of universes end up with you as the winner.
Nice. So there's some equally real world out there. If I was to go and try to buy a lottery ticket as I'm buying it, it would end up with me being very, very rich. It's kind of
Not,
reassuring.
yeah, not necessarily equally real because of the probabilities involved. So if I can end with anything, it's that we live in a probabilistic universe, and that unlike what Einstein said, God is a gambler, likes to play dice.
Thank you. That's very interesting content, very interesting food for thought. Thank you so much, Technoshaman, for your time, and thank you for your questions and participation, everyone who attended live. Please do remember to join us every day at 8 Central for a new podcast episode. Join us on Friday for a podcast on environmental issues with Jigmo, and keep an eye on announcements for the rest. And please make sure to follow us on YouTube and on BitChute, where you can find all these episodes. But most of all, join the Roundtable Discord server, where all of this takes place. Thanks again, everybody. Thank you, Tecnoshaman. We'll now jump out to Roundtable 1 and continue talking for the rest of the night.